Okay, so this might look a little different, but what I'm going to do is I'm going to go through this worksheet as if I were completing it as a student and what my thought process would be. Also, you're going to find out that some problems are missing instructions, meaning you have to pay attention so that you can write in the correct information for credit. So when we have a word problem, we have our rule of 3. I need to read it 3 times. My first time of reading it, I'm just going to read it straight through to kind of pick up on the general gist of the problem. My second time, I might start underlining or crossing out, and my third, I will then separate out my information. Now remember, you might have to read it more than once, more than twice, more than 3 times to understand it. More than 3 is okay. So let's read this one. David bought 3 DVDs and 4 books for $40 at a yard sale. Anna bought 1 DVD and 6 books for $18. How much did each DVD and book cost? So right away I'm seeing something. I'm seeing 2 different unknowns, and that should start signaling something to our brain. I see a DVD and a book cost, okay? So let's go back and read through this problem so that we can identify what we're looking for. David bought 3 DVDs and 4 books for $40. So I'm going to highlight David. He had 3 DVDs, 4 books, and it cost him $40. But then I come over and I noticed Anna had 1 DVD and 6 books for $18. Remember, at the end of the day, what am I looking for? How much did each DVD and book cost? Well, how do I calculate things? How do I figure out what my total would be if I go to the store and I buy 5 oranges that are $1.50 each? I multiply, right? Okay, so that concept is still staying put. Also, I have 2 different situations with the same variable. So if I go back through this, there's really not much to cross out, okay? What I need to know are my variables. My variables are going to be let D equal cost of DVD, and then let B equal cost of book. And yes, do you have to define your variables? This part right here, I am going to be looking for. You must have defined your variable. That's what it's called. When you define your variable, that is going to be a question. So now that I've done that, I need to go back through and read so I can generate 2 equations because I have 2 situations. So David, he had 3 DVDs and 4 books, and that totaled $40. Anna had 1 DVD and 6 books and totaled $18. Typically, if it's a system of equations word problem, you have 2 unknowns. You have 2 things you're looking for, which meaning you're going to have 2 equations with 2 different totals. So right now, all we're doing is we're setting these up. We're not solving them yet. So let's go look at my next word problem. So let's go back through and read it straight through. Airline fares for a flight from Dallas to Austin are $30 for first class and $25 for tourist class. If a flight had 52 passengers who paid $1,360, how many first class and tourist class passengers were there? All right, so there's a lot of information there. Airline fares from Dallas to Austin are $30 for first class, $25 for tourist class. If a flight had 52 passengers and they paid this total, notice what I'm highlighting in different colors. The flight had 52 passengers. Those passengers were made up of first class and tourist class. So if I go back through, I can actually eliminate some things on this one. Airline fares for a flight from Dallas to Austin. I don't really need that. Doesn't really make a difference to me where they're going. Okay. So now what I need to determine is, what are my variables? What am I looking for? Ladies and gentlemen, that really helps if you go down to where the question is. I'm looking for how many first class passengers and how many tourist class. So I'm going to put F equal first class, and then T equals tourist. Now here's what's hard for some people on this type of problem. I have two totals. Go back and look. I had a total amount of money, and I had a total amount of passengers. And remember, the passengers are made up from first class plus tourist class, and that was a total of 52. Notice how I'm writing my T as my variable. There's a little curve to it. Then I go back. Well, it was $30 for first class, $25 for tourist class, and that totaled $1,360. The more you do of these, the more you're going to see the setup. And the setup is really never going to change. So let's go down to another word problem. Now this one is very common, and it can mess with you because they're not going to give you all the information because they assume you know the information. So Sue has 100 dimes and quarters. If the total value of the coins is $21.40, how many of each kind of coin does she have? Well, let's go back through this and read this again. So Sue has 100 dimes and quarters. So total, she's got two types of things here. Dimes and quarters. There's our two unknowns. So she's got 100 of them. We know that the total value, so our total value is $21.40. You might already be thinking, okay, I got two equations. One's going to equal 100, one's going to equal $21.40. Well, they want to know how many of each kind does she have. So really, let's go write our equation. Let's go write our variables, I'm sorry. So D is going to represent the number of dimes, and Q is going to represent our number of quarters. Well, I know that there were total 100 dimes and quarters. So that means I had my number of dimes plus my number of quarters, and it equaled 100, right? But now there's a dilemma. Total value. Okay, well, I know it's got a total, right? $21.40. But let's think about this for a second. Can I total the D plus Q again? Is that possible? No, it wouldn't make sense because that's just the number. I'm looking at a value. Well, here's the thing. Where am I getting 0.10? This is the value of a dime. It's assumed you know it. Plus 0. And I'm going to move this over a bit. 0.25Q, because this is the value of a quarter. And no, they will never tell you because they assume you know it. Always, 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 always. So remember, all I wanted on those three were the setup. Okay? We'll solve them later. So this is a big one. I'm reviewing something here. I don't have the instructions. You need to write them in. I'm not going to write them in. You need to listen and write them in right here. Consider the following system of linear equations. Underneath part A, I want you to graph the system, and part B is to write its solution. Okay, So you need to write that in as instructions. But if I'm looking at this system, I can't graph until they are y equals. So let's go make them y equals. If I have 2x minus 2y equals negative 14. Subtract 2x. Ladies and gentlemen, some of you are not bringing the x with your 2. So negative 2x minus 14, okay? This here is all one term that I want to bring over. Now, this negative here has to stay with the 2. So I'm going to divide it by negative 2 so that I get y equals 1x plus 7, because a negative by a negative is a positive. So my slope is 1 over 1. My y-intercept is 7. Put a point here, go up 1 over 1. I can also down 1, left 1. Okay, ladies and gentlemen, I just graphed the first equation, okay? So I'm going to actually fix my line. I don't like it as much because it does need to be perfect, only for graphing purposes. Okay, so go solve your other one. 3x plus 6y equals 3. Subtract 3x, subtract 3x. 6y equals negative 3x plus 3, and there's a negative there. Divide by 6. Y equals negative 1 half x plus 1 half. So ladies and gentlemen, let's take a look at how I'm going to graph this, because my slope is negative 1 half and my y-intercept is 1 half. That means I'm going halfway. This is my y-intercept. But when I go down 1, I got to go all the way to the same point and over 2. So I'm in the halfway marking. Up 1 over 2. I can go up 1 over 2. Go up 1 over 2. So right there is my intersection point. That is my solution. And sometimes, ladies and gentlemen, that might happen. So really what you need to look at is a value, and I would then, if I had to give a solution, I would just solve this by elimination and get my ordered pair. Even though I had to graph it, I just go solve by elimination. So I want you to take a look. This next problem, it says, which correctly explains the number of solutions of the following system of linear equations. You have two options. You can just go solve it. Find your x, find your y. Or there's another strategy. If I took this equation and solved for y, so I'd add 2x plus 2x, I get 2y, 2x plus 10, divide by 2, I get y equals x plus 5. So this first equation actually matches the second, correct? Meaning it's the same line. So think about what happens when you graph a system and it's the same line. Right, there's infinitely many solutions. So go look through. It says the graphs of the line are parallel. Well, I can cross that out. They're not parallel. They're the same line. The graphs of the lines that intersect at one point because they have the same slope and same y-intercept. Well, so they have the same slope, they have the same y-intercept, but they're intersecting at more than one point. So that's not true. They intersect at one point because they have the same slope but different y-intercepts? No. So let's just confirm our last one. The graphs are the same line, that's correct. Same slope, same y-intercept, infinitely many. There we go. So our entire statement has to be true, okay? So I want you to try this last one. If you get it right, you will get 10 hero points. And I will be looking for your work with your handwriting for this problem.